Okay, here in example C, we see that we have two fractions. We are being added together here, and so therefore finding an LCD is the strategy that makes the most sense. And so that least common denominator is going to be 1 plus sine x, and I'm going to be very careful to write that in parentheses, multiplied by cosine x. And so this first fraction already has the 1 plus sine x. It needs the cosine x, and so we're going to multiply this cosine x by another cosine x, and that's going to give us cosine squared of x. Plus, since this is a plus sign here in the middle, this fraction needs 1 plus sine x in the denominator. So we're going to multiply this 1 plus sine x times another 1 plus sine x, and so that will be 1 plus sine x times 1 plus sine x. Okay, in the numerator, I'm going to keep going by actually multiplying this stuff out. And so I'm going to have cosine squared x plus 1 times 1, which is 1, 1 times sine x, and sine x times 1 is going to give me 2 sine x, and then sine x times sine x is going to give me sine squared of x, divided by my common denominator, which is 1 plus sine x times cosine x. Now, keeping in mind the target is 2 secant x, which I really know, and I'm not going to work on both sides, I'm really just thinking this through in my mind. That target is really 2 over cosine x. Now again, I'm not writing that as a part of a step of any work, I'm just sort of thinking about it in my head that I'm trying to get 2 over cosine x. Well look, I already have cosine x in the denominator. I'm trying to get rid of a 1 plus sine x. Well, I've got a 2 sine x and a 1 up here. If I could somehow make that a 2 legally, not just write it as a 2, but if it could somehow end up being a 2, then I would have 2 plus 2 sine x, which would give me my 2, and I might be able to do something to cancel that 1 plus sine x. Now I'm thinking way ahead here, just to try to get you to think about what is going on. And so look at that numerator and see, is there anything that could happen? And what you hopefully notice is that I have a cosine squared x here and a plus sine squared x down here, and that is a Pythagorean identity, and it gets replaced with 1. And so we're going to have 1 plus the stuff that I didn't circle in red, which is 1 plus 2 sine x divided by 1 plus sine x times cosine of x. Now, in the numerator, we can obviously collect our 1's, and so that's going to be 2 plus 2 sine x divided by 1 plus sine x times cosine x. And again, keeping in mind that target, I know I'm trying to somehow get this to cancel out, and I'm trying to be left with a 2 in the numerator. And so what I'm going to see now is that in the numerator, I'm going to be able to factor out a 2, which will leave me with 1 plus sine x. And that's going to be divided by my LCD. And so now I'm going to be able to cancel what I want to cancel. And so 1 plus sine x is going to cancel in the numerator and the denominator. That's going to leave me with 2 divided by cosine x, which using a reciprocal identity will equal to my right-hand side of 2 secant x. And so a lot of different strategies were used all at once here, but the overlying strategy that we used to get us started was to find a least common denominator. But from there, we used a Pythagorean identity, we used factoring, we used canceling, and then we used a reciprocal identity at the end to get our right-hand side. And one more time, I just want to reiterate that writing this down and having it meet in the middle, that's not okay. You can just sort of think about it as that, but don't have the two sides meet in the middle. Notice how I started with the left-hand side, and I worked all the way through to show that it equaled the right-hand side. Okay, here in letter D, I'm going to illustrate how trig conjugates work, and so I'm going to start on the right-hand side, which is cosine x divided by 1 minus sine x. And I notice that there's not two separate fractions here, so I can't find an LCD. I'm not going to be able to peel because it's minus in the denominator and not multiplication. And I can't split through the denominator because that's not a thing. And so therefore, the only option really here is to multiply by a trig conjugate. And so the trig conjugate is going to be 1 plus the sine of x. And we're going to multiply by that in the numerator and the denominator. And so what this is going to end up being in the numerator is going to be cosine x multiplied by 1 plus sine x, and I'm not distributing that for a reason that you'll see here in just a minute. Divided by 1 minus sine x times 1 plus sine x, which is trig conjugates. And so therefore we only have to multiply the first terms, and so 1 times 1 is 1, and the last terms, which is going to give me minus sine squared of x. Now just for a second, why did I not distribute in the numerator? Because look at the target. The target has 1 plus sine x already in the numerator. And there is my 1 plus sine x. And so I'm trying to get that to stay there. And if I distribute it, it's not going to be there. And so I need to leave it undistributed and hopefully find a way to cancel this cosine x. Now, in the denominator, we are working with a Pythagorean identity. And so I'm going to have cosine x multiplied by 1 plus sine x in the numerator, and in the denominator we have a rearranged version of our first Pythagorean identity that says sine squared x plus cosine squared x is equal to 1. And so what I want to do is I want to solve for 1 minus sine squared, and so 1 minus sine squared x is going to equal to cosine squared of x. And so that's what my denominator is going to become by a Pythagorean identity. And what I notice now is that my cosine x in the numerator is going to reduce with my cosine squared x in the denominator. And so cosine x in the numerator will completely go away. Cosine squared in the denominator will just become cosine x. And so what we're going to end up with then is 1 plus sine x divided by cosine x, which is exactly what my right-hand side was. Okay, we're going to end with what is probably the easiest proof that we're going to do in these notes, and that's 1 plus sine x all divided by cosine x. We want to show that that's equal to secant x plus tangent x. And so I noticed that this is a fraction, but it's not two fractions, so it's not going to be finding a common denominator. I'm not going to be able to peel since I've only got one thing in the denominator, but I am going to be able to split through the numerator because I only have a single term in the denominator. And so if I split through the numerator, this is going to say 1 divided by cosine x plus sine x divided by cosine x. And now, looking at the target, I need this to say secant x. Well, I know that 1 over cosine x is secant x by a reciprocal identity, plus tangent x, and I know that sine x over cosine x is tangent x because of a quotient identity. And so we were able to get there just in 2 lines by splitting through the numerator first and then using our basic trig identities to get to the right-hand side. And so that's going to do it for proving trig identities. You have a lot of problems to practice. Some of them are easier, some of them are more difficult, but I would encourage you to give them all a try. And as always, if you run into trouble, please feel free to reach out.